Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 7.3, solving linear systems by adding or subtracting. So this is a basic way, and you'll notice today that all the systems are very special here. All right, so number one, check if 2, 2 is a solution to the linear system. So once again, we are just trying to see if 2, 2 lies on both of these lines. In other words, it'll be the intersection. So that means it should be a solution to both lines. So let's check it on the first one. We'll do that one in green. So I'll replace x with 2, and I'll replace y with 2. And we'll put a question mark here. 4 does equal 4. So this point does lie on the one I have circled in green. So now we'll check the other one. So we'll plug in y as 2. We'll plug in x as 2. And we say this is 2 times 2, which is 4, and 4 minus 4 is 0. So this is not a solution to the red line, the one circled in red here. So it will not be a solution to the system. Okay. All right, number 2, solve this system by the graph and check method. So the graph and check method, remember we want to graph each line. So I'll graph the first one in blue. Okay. 2x minus 3y equals negative 6. For this problem, I'm going to use the x and y intercepts because it's in standard form. So we're trying to figure out what are the x and y intercepts. So remember, to find the y-intercept, we let x value be 0, and to find the x-intercept, we let the y value be 0. So in our equation, if x is 0, then this part would scratch out, and we would solve for y, and we would get 2. So 0, 2 is right here on the y-axis. Okay. If we let y be 0, so this was 2x here. So we let the y be 0. We cross out the y part, we solve for x, and we get negative 3. So the x-intercept is negative 3. So our slope of this is 2 up and 3 right. So I could go 2 up from here, 1, 2, 1, 2, 3 right, or 2 down and 3 right to get new points. So here is the line circled in blue graphed. Now I'll circle the other one in green. This one's a bit easier to graph. This is our y-intercept. And our slope is 1 over 1. So we put a point at 4, and we go up 1 and right 1. Or we can continue going backwards this way. All right, so if we have graphed clearly, I believe the intersection is this spot right here. Okay, so let's check it. This is at 1, 2, 3, 4, 5, 6. So negative 6 and negative 2. Now it is called the graph and check method, so we do have to check. All right. So I'm going to do my 2 checks. Our first one is 2x minus 3y equals negative 6. I replace x with negative 6. I replace y with negative 2, and we're testing if the answer is negative 6. So this is negative 12 plus 6 equals negative 6. So negative 6 is negative 6. So it does work for the first one. And for our second one, we plug y equals x plus 4. So I replace y with negative 2. I replace x with negative 6. And we have a question mark here. So negative 2 equals negative 2. And that works on the second one. So our solution is negative 6, negative 2. Okay, there's our answer. All right, number 3, solve the linear system by using the substitution method. So we're practicing both methods that we've learned so far. All right, step 1, we solve for either x or y in either equation. So this is equation 1 and equation 2. I'm going to take equation 2 and solve for x. It's the easiest one to do. So in equation 2, if I solve for x, I don't have to do any work at all. X is already solved for. All right. Step 2, since I've already used equation 2, I have to use equation 1. So I'll go ahead and copy that down. And then I'm going to replace the variable that I solved for in step 1. So in place of x, I'm now going to put 16 minus 4y. That's what x was equal to from step 1. And now when I do that, I have no x's left. I have only y's. So I'll go ahead and distribute. This is 48 minus 12y plus 4y equals 8. This is 48 minus 8y equals 8. I'll subtract 48 from both sides. I get negative 8y is equal to negative 40. So that meant y was 5. And then in our final step, we plug that y back into either equation. It doesn't matter. So I'm going to plug it into equation 2. So in place of y, I'm going to put 5. And that gives me for x 16 minus 20, which is negative 4. So my final answer is going to be negative 4, 5. Now you don't have to check this, but it's always a good idea to do a mental check just to think about it. So that's really 3 times negative 4 in our first equation, which is negative 12, plus 4 times 5, which is 20. So negative 12 plus 20 does make 8. So it does work in the first one. And in our second one, 16 minus 20 is negative 4 for the right side. 4 times 5 is 20. And negative 4 is what x is. So it works in the second one also. All right, so this concludes our warm-up. Let's check the next page and see the new stuff. Okay, on our second page, we have some directions on how to solve a linear system by elimination. And these are basic problems. So we'll learn a little bit harder ones next time. Okay, so step 1, we're going to add or subtract the system to create a new equation that has one variable eliminated. So that means only one will be left. Then we're going to solve for the remaining variable in your new equation, which is a 1-step or 2-step equation. It shouldn't be bad. And then we'll substitute it back in just like we did in the substitution to get the other variable. So here is an example. Solve this system using the elimination method. So we have 2x plus 3y equals 11. And negative 2x plus 5y equals 11. Notice that the x coefficients are opposites of each other. If we were to add 2 and negative 2 together, they would cancel out. And that's what we're going to do for step 1. We're going to add this system to eliminate the x terms. Sometimes we'll subtract, sometimes we'll add. In this case, we're going to add, and that's because the x's are opposites of each other. So when I add 2x and negative 2x together, they get eliminated. That's why it's called the elimination method. When I add 3y and 5y, they make 8y, and when I add 11 and 13, they make 24. So now I've got this new equation, very short 1-step equation, and I solve it for y. Divide both sides by 8, and I get 3. Okay. Step 3, substitute 3 for the value of y into either equation. I just happened to choose the first equation, but you could choose either one. So in place of y here, I stuck in a 3. Okay, and then I worked it out. 2x plus 9 is 11. I subtracted 9 to both sides to get 2 on the right, and then I divided by 2 to find out that x is 1. So the solution to the system is 1, 3. All right, so it's a really fast method, but it only works when the coefficients of one of the variables is either the same or opposites of each other. All right, so let's take a look at a couple examples. Solve each system using the elimination method. So here, once again, the x's are opposite each other, so we could add, when they're opposites, we add. So we do 3x plus negative 3x, that makes 0x, so that gets eliminated. 4y plus 5y makes 9y, and 8 plus 10 makes 18. I then divide both sides by 9, and I get y is equal to 2. Okay. I plug that 2 back into either equation, it doesn't matter. So I'm going to put it into the first one. All right, so this will be 3x plus 4 times 2 equals 8. That's 3x plus 8 equals 8. 3x equals 0. So when I divide that by 3, I still get 0. So my answer here is 0, 2. Now, as always, you could do a check. Just plug them back into both and see that it works. And in this case, this is easy to plug in because 3 times 0 just goes away. So 4 times 2 is 8. That works out fine. Negative 3 times 0 goes away, so 5 times 2 is 10. So that one would also check out fine. A check is not required in here, but it's a good thing to see, and then never miss a problem. All right. The second one, if I tried to add this system, I'd get 12x and 12y, so it wouldn't work. But notice the y's are the same value for their coefficients. When that happens, we're going to do subtraction to the system. So I'm going to do 5 minus 7, which is negative 2, and put the x back. 6 minus 6 is 0y, so 0y is just 0, so the y's got eliminated. And 4 minus 8 is negative 4. And then I just solve the resulting one-step equation. Divide both sides by negative 2, and that gives us 2. And then I plug that 2 back into either one, so I'll plug it into the first one again. So 5x plus 6y equals 4. 5 times 2 plus 6y equals 4. That's 10 plus 6y is 4. So 6y is negative 6 when I subtract the 10 to both sides, and y is negative 1 when I divide by 6 to both sides. So the solution is 2, negative 1. And once again, you should do a check, just a mental one at least, just to check yourself. Okay. All right, this concludes our second page. Let's take a look at the last one for today. On our last page here, we have 2 more example problems, and then we have 2 word problems where we just write the system, but we do not have to solve. So some more practice. All right, number 3. If I add up this system, we get 4 plus negative 2. That would make 2. And then the y's would be negative 3 plus positive 3, and that would be 0y. Remember, whenever the coefficients are opposite, it's add. And whenever the coefficients are the same, it's subtract. If you add a number to its opposite, it makes 0. And if you subtract a number from itself, so like 6 minus 6, it also makes 0. So in this case, it's going to be add. So this will give me 2x, but the y's will go away. And 5 plus negative 7 will make negative 2. So when I divide both sides by 2, I get negative 1. And then I plug the negative 1 back into either equation. So I'll plug it into the first equation this time. 4 times negative 1 minus 3y equals 5. That's negative 4 minus 3y is 5. And then I'll subtract 4 to both sides, or add 4, I'm sorry, will give us 9. And then divide by negative 3 will give us negative 3. So our solution here is negative 1 for x and negative 3 for y. All right, last one. So there's a problem here. All of them so far have always had the x's lined up, the y's lined up, the equals lined up, and the numbers lined up. And that has to be the case here. So we have to do some work before we can solve it. We're going to leave this one exactly the same. But for the second one, I'm going to subtract 3x to both sides. And I'm going to go ahead and write it in the front so the x's will be lined up. 2y is not going to change, and on the other side, 6 is not going to change. Okay? So now I have x's lined up, y's lined up, equals lined up, and the numbers, the constant terms lined up. So in this case, it's going to be add again, because the coefficients are the opposites of each other. So when I add up this system, I'm going to get x's eliminated. I'll get 6y, and then negative 6 plus positive 6 makes 0. So divide through by 6, and you get 0 still for y. Then I'll plug it back in. We'll go ahead and plug into the first one. So 4 times 0 equals negative 6. So that's 3x is negative 6, and x is negative 2. So the solution is negative 2, 0. And it's fine to have a point on the x-axis be your solution. This is just the place where these two lines cross, a point on the x-axis. All right, define variables and write a system of equations that could be used to solve. So number 5, the difference between the length and the width of a rectangle is 7 centimeters. The perimeter of the rectangle is 50 centimeters, and we want to find the length and the width of the rectangle. So remember, the last sentence usually tells us our variables, so we'll let L equal the length and W equal the width. And then we use our other sentences to write two equations. So our first one says the difference between the length and width is 7 centimeters. That means if I subtract the length and width from each other, the difference is the answer to a subtraction problem, I should get 7. Okay, now it doesn't really matter which one you put first here, but this would be fine. We could say length minus width is 7. So the difference between these two, usually we'll put the left one first. Okay. All right, the last question says the perimeter of a rectangle is 50 centimeters. So perimeter formula is usually 2 lengths plus 2 widths is equal to the perimeter. Well, in our case, we know the perimeter already, so we'll place 50 for perimeter, and the perimeter is 2 lengths plus 2 widths. Okay. Now we could solve this easily. We would just mix it around so the L's are lined up, the W's are lined up, the equals and the coefficients are lined up. All right. And then we would do our elimination method. But in this case, we have to do a little bit of work before we'd be able to do it because the coefficients wouldn't be the same or opposites. Okay, so we'll learn how to do that kind of problem in the next section. All right, our last one. At a meeting for Skateboarders Anonymous, there are 7 more boys than girls. There are a total of 43 total kids present, and how many boys and girls are there? So we'll let B equal the number of boys, and G equal the number of girls at the meeting. Okay, so our first sentence says there are 7 more boys than girls. So there should be more boys than there are girls. So the boys should be bigger than the girls' value. So I'd have to add 7 onto the girls to make it equal. And then it says there are 43 total kids present. So that says the boys plus the girls should equal to 43. So here's our system of equations. We have the variables, and we have a system here that we would have to solve. All right. Tonight, before you come to class, this is a quick thing. You need to complete the Khan Academy, solving systems of linear equation with elimination, and the basic one. That's when the coefficients will either be the same or complete opposites of each other. All right. So this shouldn't take long. If you've done 3 or 4 problems and you keep missing them, come back and watch the notes over again because you really didn't learn anything from them. All right, I will see you in class next time, and this will count as a grade the second that you walk in, so it needs to be done before you come.